All right, so to end our discussion about these numerical approximations of integrals, we're gonna look at trends in how the rules over or underestimate the true value and by how much. Okay, there are some complicated formulas related to that error estimation. We're not gonna worry about those too much in this class. You can always look them up later on if it turns out you do need them at some point in your career. Okay, so we're going to look over one more activity. So we have these three functions, 2 minus x squared, 2 minus x cubed, and 2 minus x to the fourth, all considered on the interval 0, 1. And it'll be very helpful if you keep your answers in fraction form as much as possible, because we want to get as exact an answer as possible. Once you've gotten the fraction at the end, if you want to divide it out to get a decimal approximation, that's fine, but keep everything in fractions as much as possible so that we maintain precision. Okay, so part A is asking you to sketch graphs of each of these functions. Compute L1 and R1. Remember, that's just a single rectangle in each case. Compute M1 and T1 for each of the three functions. And once you've done M1 and T1, you can compute S2. And then the three integrals, you can actually do them. So you do them. And then for each of these, I want you to compare the results. What patterns do you observe? So pause the video, give that a try, and then come back. Okay. So to just kind of sum up what we've talked about, we like approximation of integrals because there's certain integrals we don't know how to do. And for example, integral from 0 to 1 of e to the negative x squared dx. And then we have this new rule, the trapezoid rule. We compared it with the midpoint rule, and we used those two. By analyzing the errors of these two, we created, well, we didn't create, Simpson created a rule that's called Simpson's rule that actually makes a much better approximation. And as I was mentioning earlier, you could interpret Simpson's rule as making areas under a bunch of parabolic pieces, but we didn't focus on that. So here are the exercises for this section. Go ahead, give them a try. I will write on Canvas which specific ones I want you to work on. But that's it for numerical integration. I hope these videos have been helpful, and I will see you in the Zoom.